Hello everyone, this video is a Vrep tutorial. So if you're just starting out in doing your project in Vrep and you might be struggling to find it easy to understand. Okay, let's understand Vrep here. To get started, make sure you have the latest version of Vrep installed on your computer, which is available for free on the official website of Coppelia Robotics. This software is available on Windows, Mac and Linux platforms. Vrep. VREP, V for Virtual REP Robot Experimentation Platform, is a general purpose robotic simulator developed by Coppelia Robotics. VREP is based on a distributed control architecture. Each model or object can be individually controlled via an embedded script, a plugin, a ROS node, a remote API client, or a custom solution. So the controllers can be written in C, C++, Python, Java, Lua, MATLAB, Octave, and Urbi. So we'll see Lua here in this tutorial. And these are the options in VREP. So when you open VREP, this is the main window, application window. The window which is this is called the application window, and the one behind the application window is the console window. So in this window we have application bar, menu, scene hierarchy, toolbar, page, scene, views, dialog, status bar, and model browser. Okay, let's start doing it. So right now I'm on Mac, and the procedure and options, everything is same for Windows and Linux. Okay, like we have seen in the previous slide, and this is the model browser here. So this is the top left corner of the screen. It is called model browser, and different models are there in this model browser. You can easily scroll it here. Mainly we have like most of the time we use these robots. In robots we have mobile and non-mobile robots. So non-mobile, I have selected non-mobile robot, and here, right over here, we can see all the non-mobile robots built in Vrep software. So these models can be imported into the scene. You can simply drag and drop it here. Yes. Okay. Yes. This is our scene. This particular blue colored floor, this whole thing is called the scene. So this is the MTB robot. The names of the robot is displayed below. And in mobile robots we have many robots, and these robots, they get new robots are added in VREP with the introduction of the updates. So, and there are different components are also there. You'll see, yes, here we have actuators. So this is the generic prismatic motor. You can simply drag and drop it here. Yes, I'll zoom it for you. Okay. Yes, this is the generic prismatic motor, and we have a grippers also. We have a two-hand gripper, three-hand gripper, simplified and modified grippers. Yeah, and we also have a suction pad in grippers. Okay, and for locomotion we have all these things, and you can browse all these whenever you find whenever you find um, whenever if you have installed VREP in your computer, you can browse all these models. And let's start doing it. Yes. Here are the different tools that are useful in VREP, and these tools are placed here. In the VREP you will see all these tools above the scene, And let me explain each of these. And the first six are camera navigation, and this one, seventh one, is the click selection, and these two comes under object or item manipulation. And this is for assembly, disassembly, and this is for DNA transfer, undo, redo. And these all are self-explanatory. Let us see each of what is the benefit of each of these tools. Yes, see, you can zoom in or zoom out the scene here, and you can even adjust the size of these, or you can also close this. Okay, see, for zooming in the screen, you can just scroll the mouse wheel up and down, up and down. Okay, and for rotating, this is called the camera pan. If you enable this camera pan and you click the left mouse button, and this is how it works, the camera pan. And if you want to rotate the scene, camera rotate, and see, just enable it and see what happens when you press left mouse button and then drag. This is how it works, camera rotate. Okay, you can practice it on your computer. And this one is camera shift. If you enable it and press the left mouse button and then drag, it will zoom in and zoom out. And if you want to fit the entire floor on the screen, you can simply press fit to view. Yes, the whole scene will be fitted exactly on your screen. Okay, and see, this is the object or item shift, click selection, sorry. Okay, you can select it here, and see, I have selected suction pad here, and the suction pad that I have selected is highlighted in the scene hierarchy. This is how it is highlighted. And yes, right, you can even do the alternate way, do it in the alternate ways. You can select any object in the scene hierarchy and it gets highlighted in the scene. And this is the scene hierarchy, don't forget it. And this is the important, very very important in doing your vrep models. And if I have selected this one gets highlighted. And if I want to see the components in the MTP robot, I can simply expand this plus button. See, I can minimize, I can expand, right? So if you expand, it will show up all the components that are present in this robot. See, now I have selected this one. Now press fit to view, and this particular robot will be fitted to the screen. And yes, see, I have selected rectangle here, and the rectangle in the scene got highlighted. Similarly, it works for, this is the revolute joint. Similarly, it works for revolute joint and any other model. All the things it gets highlighted. So you can edit it the way you like. You can even add it any way you like, anywhere you like. Sorry. Now see, this link is there. Now if I don't want this link, I can simply select it and press delete in your keyboard. Yes, delete. Now see, it got deleted. And if you want to undo it, you can simply press Ctrl Z if you are on Windows and Command Z if you are on Mac. And here is the rectangle. Now you can edit this rectangle by double clicking on this icon. Just double click it, and this particular dialog box will open. This dialog box name is scene object properties. In this scene object properties, you can modify this object. The object that you have selected, you can modify it. So for example, you can adjust the color of it. Adjust color, ambient. Now if you want it to be appeared as pure red, then RGB is selected here, are visible here, and yes, R1 high, G0, B0, and then close it, and you don't have to press OK. Vrep saves automatically, auto save option is there. Yes, we have edited the color now. You can even add the texture to it, and yeah, you can even modify the geometry. For suppose if you want to increase the height of it, now what you do is untick this key proportions, and and here is the z dimension. In z dimension, what is there? E power minus 1, 1 into e power minus 1, it means it is 0.1 meters. All the units in Vrep are in meters. It is now 0.1 meters. What I want is I want 0.5 meters. Just input 0.5 and click apply. Yes, the dimension of the rectangle has been increased now. Now you can close it, and you can close this dialog box. Okay, so you can try this for um, different components. For example, if you want to do it for, this is the revolute joint now. Yes, this is it, revolute joint. Now if you want to edit the properties of the revolute joint, just double click the icon, and this particular dialog box will be opened. Now let us see this revolute joint is of some size. It has some size, and that is 0.15 meters in length. The revolute joint is 0.15 meters in length and 0.1 meters in diameter. Now I want to increase it from 0.15 to 0.5. Just delete one and 0.5 and click enter. Yes, the size has now been increased, but uh, you are unable to see the revolute joint. It's because the revolute joint is in 10th layer. I'll explain you what this layers is. Layers is nothing but the visibility. Now if you want the revolute joint to be visible, then make sure you take any one of the first row. Yes, if you take the first row, it gets visible. If not, if nothing is ticked in the first row, it gets invisible. Visible, visible. In any layer in the first row will make the component visible. Now yes, let us change the length. 0.15. Okay, 0.15 is better, and the diameter is little big, 0.05. Okay, yes, it's correct now. Okay, and in this dialog box there are different options. Mode, here we have a passive, inverse, kinematics, dependent, motion mode, torque or force mode, and we'll see the what are the benefits of using in IK and torque mode. Okay, now you can enable the motor. Like in IK mode, a motor can't be enabled. In torque or force mode, motor can be enabled. What happens when you enable a motor? It starts rotating like a motor. I mean to say that Vrep understands that there is a motor in it, and you can set the target velocity and torque for the motor. You can even give the control loop. PID control is available, and custom control is also available. And see, this custom control means you can write a script for this. Like if for a PID, product integral derivative, you can set the factors for P and I and D, and you can this is the script. Like this is written in Lua language, Lua script we call. Okay, and yeah, so till now we have seen the models that were already present in Vrep. The robots, all these robots are present in Vrep. You can simply drag and drop it. Now let us see how to create your own model in Vrep. Let me delete all these things. Now go to add primitive shape. mm, Cylinder. So if you select cylinder, it will ask what is the x dimension, y dimension and z dimension. So cylinder doesn't have y dimension, so it's not visible here. So x dimension, let us say zero 0.1 meters, and y size is y will be the height of the cylinder and x will be the radius of the cylinder. We need good height, let us say 1 meter. We need it 1 meter. So press OK. Yes, cylinder has been created here. Right now, this is how you add objects in Vrep. Now if you want to have a cuboid, add a cuboid of these dimensions. Okay. Yes, you see cuboid is placed on the bottom of the cylinder. Now what now if you want to move this cuboid, just select the cuboid in the scene hierarchy and press this button, object or item shift. Yes, just selected now. Yes, now you can simply drag it with your mouse like this. This works for x and y dimensions. Or you can even input the coordinates where you want the cuboid, like x coordinate, or let us set it at origin. Y is 0 and yes, z, the height of the cylinder is 1 meter. No, okay, let us move it to 1.1 meter z coordinate. Yes, you see this has been shifted to top because the cylinder is at the origin 0 0, and the cuboid is also at 0 0, but y z, sorry, z is given selected as 1.1 meters. This is in meters, and for understanding purpose please refer this coordinates. X is in x, the red colored axis is the x, and green colored is y, and blue colored is z. And similarly these axes can be viewed, is present for all the objects. Now close this and then let us rotate. Yes, you see the for the cuboid, the blue colored z is in the top. Yes, it is matching with the world coordinate frame, and z is in facing towards us. Yes, x is facing towards us, and the blue is facing towards us, and green is facing that way, y. Yes, now 0 0 1.1. Okay. uh, Now we have added a cylinder and a cuboid to our scene. Now if you want to add a revolute joint between these two, or let us say let us take the prismatic joint. Now I have added the prismatic joint to the scene. Now the prismatic joint is at the bottom. By default it goes to origin 0 0 and 0. Now I should translate it. to a height 1, 0, 0 and 1 meter. Z should be 1 meters. Yes, this is where the prismatic joint is located. Now see, I'll press the play button. This is the start simulation button, and this is the pause, and this is the stop simulation. Let us see. Nothing has happened. With the influence of gravity, the cuboid has fallen down, and when I press the start simulation button, see the changes that were happened in the scene hierarchy. There is a tick and error. Stop. Okay, you see for this there is a error button here. It's because the prismatic joint has no relation. It has been placed at a particular location, but it was not linked with anything. It should be given parent and child relationships. Now let us see how to give parent and child relationships. Now we have a cylinder here, and the child of the cylinder should be the prismatic joint, and the child of the prismatic joint should be the cuboid. That is how it should be. Now what you do is simply drag this prismatic joint and drop it in the cuboid. Oh, sorry, drop it in the cylinder. Yes. Now see, cylinder is the parent and prismatic joint is the child of the cylinder. Now cuboid should be the, now drag the cuboid into the prismatic joint, and this cuboid will become the child of the prismatic joint. See, expand. Yes, see these arrows. Cylinder's child is prismatic joint and prismatic joint's child is cuboid. Now let us see what happens. There is no error here. You see there is a tick mark here. It means there is no error, but our prismatic joint is not working at the moment. Now in order to make the prismatic joint, what you can do is you should add a script. You should either add the script or you should enable the motor for this. Motor enabled, target velocity be 10 meters per second. Lock motor, close. Let us simulate it. Oh yes, it is working. Stop. Okay, it looks like 10 meters per second is a very large value. Let us see 2 meters per second. Right, e power minus 2. E power means it is 10 power minus 2. Don't get confused. Now see, now what I have done for the revolute joint, for the prismatic joint, I double clicked the icon here and this particular dialog box has opened. Now in this dialog box I have clicked show dynamic properties dialog. In this dynamic properties dialog I have enabled the motor, and the target velocity I have given it some value. Say it is 0.0003 now. Press enter and then close this dialog box. It gets saved automatically. Now press play and see how the prismatic joint is working. It is raising the cuboid slowly with a particular velocity that we have defined it, and this is one way of enabling the joint. And the other way to enable the joint is to add a script. Now right click the prismatic joint and then add yes, associated child script. So we have two things here, non-threaded and threaded. We'll see this in the coming module. Now let us see other options that were available. Yes, this is object or item shift. You can use this to shift the object like in the x, y and z directions, and this is used for rotation. uh, let us see how it works. Select the cuboid and click rotate, and take your mouse there and just drag, just click left click it and then drag your mouse, and this is what happens. So I don't suggest you do it this way. What I suggest is, go to this dialog box instead of rotating it with the mouse, which is quite confusing and not accurate. Go to dialog box and then put 0 0 0 with respect to world frame. See, we have a relative to. How do you want the object to be rotated? Related to we have a world frame and we have a parent frame. So make sure 0 0 0 is ticked here. What it means is alpha, beta and gamma. Alpha is with respect to x, world coordinate x, y, beta is for y, and gamma is for z. Now if you want to, what I suggest is, always tick on frame. This is quite easy. Yes, I have zoomed it for you. Now around x, what I'm gonna do is I'm gonna delete this and I'll input 20. Now what I want, this how I want this cuboid is, I want to rotate it about 20 degrees with respect to on frame. On frame is nothing but the x, on x. It means on x is this red colored. Now see what happens. 20 degrees, the value is, the input is in degrees. Now press rotate selection. Yes, it has now rotated to 20 degrees. Now if you press it again, it will be rotated to 20 degrees from this position. 20 20 again, and again press this, rotate 20 20 20 20 20. This is how it gets rotated. Now if I want to rotate it about z, for 30 degrees, what you do is delete this 20 and then press 30 and input 30 in the z. I'm deleting this 0 because if I enable 20 here, what happens is, it rotates in both x and z direction. We don't want that. We want it to rotate only in z direction. 0 0 z. Z is the blue colored. Rotate. Yes. You might have understood it clearly by now. For even you can practice it on your computer. Okay, and this is the rotate option, and this is the assemble and disassemble. So this is used for assembling the parts like the more grippers and all that, for assembling this. And this is undo, and this is the redo button. And these are the different physics engines. We have 5 different engines that are given by default in Vrep. This is the dynamics settings. So play, pause, stop. Okay, let us play what happens. Okay, it's working fine, no problem. And see, now I've clicked play. If you press the rabbit, what happens is the simulation gets faster when you press the rabbit and gets slower when you press the tortoise. You see, it's going very 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 slowly. Just press the rabbit, it gets faster. Okay, and this rocket is for making the simulation even faster. And see, this rocket is not enabled now. So is the rabbit and tortoise. It's because the simulation has been stopped. These three options will get enabled only when you start the simulation. Unless if you don't start the simulation, this won't be enabled. And this is the page selector. Let us see what happens when I click play page selector. Just click it, different pages will open. I mean to say that different views are opened. So page 1 is the normal view, and page 2 will be your left side view, right side view, mm, some different views are there. And page 6 has the top view, and page 7 has combined views. Like we have a 4 different views in page 7. Let us see what happens. Now this is the normal top, sideways. Now if I zoom in one page, if I'm zooming in this page, the views in other pages will also be zoomed here. And I suggest that you can use this for you can use this particular page for different for positioning and verifying whether your object is placed correctly or not. Okay. Okay, so till now we have seen how to add our own robot here, and you can add any number of links according to your wish. And you can also import, you can model your CAD. You can get a CAD model from any of the CAD modeling packages like SolidWorks, CATIA, NX, AutoCAD, but make sure it is in STL format, because Vrep accepts importing of STL, and this is how it imports. Import, go to file, import mesh, and here it will ask for STL, OBJ, and DXF. STL is better format, I guess. So you can import it. You can import the CAD model into Vrep through this import option. Like we have these 3 formats. Now if you want to save this scene, go to file and then press save scene, and it gets saved in TTT format, .ttt format. You can save it anywhere you like. And see here, there are many files that are already present in Vrep TTT format. When you install Vrep, all these files are provided by Vrep, and these files are the examples. uh, let us open one of them. Mm, okay, let us see this inverse kinematic manipulator.ttt file. Open and open. Mm, this has been open. Let us open another. Yes, UR5 robot with RG2 gripper. RG2 grasping. Okay. Mm. This scene has been present in Vrep automatically. When you download Vrep, all these scenes are already present there. Now these scenes are for reference. Now press the play button and the robot, it functions. So this robot is present here. UR5, yes, this is that robot UR5, and this gripper is also present in the gripper section here. And this is the conveyor belt. There is a conveyor belt here somewhere in the components. So yes, this is for understanding purpose. I have stopped the simulation. This is for understanding purpose. So this is the script icon. So if you double click it, the script that this robot is working on will be the script can be seen here. And this script is of 138 lines. 138 lines of coding has been done, and this script is not very simple. Like you can easily understand the script if you go through it carefully. Mm, and you can add your own script for your robot. Previously we have defined a robot, a small robot with a revolute joint, so you can add a script and you can make the robot work according to the script. Go to file. Okay, recent save. Yes, and in this import you can import the path, or you can highlight the for a highlight field export options. You can save the graph, like velocity graph, acceleration, torque graphs, tip velocity. Many graphs can be plotted in Vrep, and you can export the graphs into the Excel format, MS Excel Word format, and the the file extension is CSV, and MS Excel has functionality to open this CSV into Excel. So you can even export the IK, inverse kinematic content of it. Okay. Now in this add section we have many uh, objects here to add. We will see in the coming modules how to add what are all these options and all. And plugins, yes, this is what I was saying. Collada plugin, Collada import export is there, and URDF import is there. This Collada is for uh, this Collada works for Blender, and this URDF import works for SolidWorks. And your SolidWorks is a paid software, whereas Blender is a free software. Let us see how this Blender. This Blender is available for Mac and Windows versions. Double click the Blender and this gets open. Yes. Okay. There is a keyboard in this Blender. Now you can, what you can do is go to file. You can assemble all the HTML files in Blender, and then you can export it in the Collada format, and you can export it in the Collada format, and then you can import it in Vrep through this plugin called Collada import export. Let us see how to do it now. Once you have finished assembling your all your components of the robot in Blender, go to file and go to export. Collada option is there here, Collada, and just select a location, and then yes, export to Collada. And once you export it, you can import it easily in the Vrep. uh, So I suggest that you use SolidWorks URDF import. It's because all the revolute joints will be added automatically in the SolidWorks, but in the case of Blender, the revolute or prismatic joints are not seen. They are not um, automatically added in the Collada. You have to add it manually. So, and if you have any kind of doubt, you can go to help manual in the Vrep here, help topics. In your browser, this gets opened. Vrep help page will be opened. This is like a bible for Vrep. This has many this is a documental tutorial. You can see how to, if you have any kind of doubt, you can refer this manual. It has almost everything, like different modules are there: calculation module, collision detection module, the procedure for how to perform this modules, IK modules is also there, and different API functions. Like for writing a script, you need these API functions. Regular API is present, and the syntax for this is given here, like yes, C synopsis, yeah, Lua synopsis. we are writing in Lua script now. That's why we need to refer this Lua synopsis table matrix. This is the function that is to be inputted in script, and this is the command, this is the synopsis that you need to input if you are working with the sim get ik group matrix. So what it does is inverse kinematics matrix will be accessed through this. Now alphabetical regular API list. Now all the APIs, like there are at least 100 to 200 APIs, maybe more than that. All are listed here, and you can open any of the. You can browse through it, all the APIs. Lua synopsis. This command is given. You can input it and make the robot function as per your need. Okay. And there are different tutorials present, like for performing the IK tutorial, uh, the procedure how to do the IK inverse kinematics is given in a detailed manner here. Like if you have any doubt, you can refer to this help section of the Vrep. Yes, and these selection are the different modules that you have in Vrep. The first one is simulation settings, and the second one is object properties, scene object properties, and this is the function. We have different calculation modules. IK dynamics module, path planning module, distance calculation modules are present, and this is for the script. This shows all the available scripts, and this is for path. This if you press this model box gets opened. If you unselect it, it gets closed. And similarly for scene hierarchy also, you can open and you can close. These are different layers, and this is a video recorder. You can record a video, launch at next simulation start. So when you press, this gets recorded into this particular folder, the folder that you have selected here.